It's happened twice now. Twice now.
What's the reciprocal that goes with cosecant? What goes with cosecant? Sine. So if you look up above, it says graph the sine or the cosine first. So cosecant, I want you to graph sine first. So when you look at the sine function, hopefully everything, you remember it. B value is 1, so the period will be 2 pi divided by 1. Critical points are 2 pi divided by 4. So your basic sine curve amplitude 1, so you're going up 1, down to -1. Where does sine start? At the midline, and goes up first. Do it as a dotted line though. So here to here to here, here, here. Do you have to do it as a dotted line? Yes. Yes, you do. Okay? Because that is not the graph, and I'll show you in just a second. It is not the graph. Now, what's the relationship between cosecant and sine? Reciprocal. So if the output for sine is 0, what's the output for cosecant?
Undefined.
1 over 0 or undefined. So anywhere we touch the 0, put a dotted line. Can't use this value. And then your graph sits right here. So I went a little thicker, different color. That U-shaped graph right there, that is the cosecant graph. You will not see anything else if you graph one of these, except those U's. So that's why you have to do the dotted line for your sine. It is not part of the graph. It only helps you get the shape. So what did we use the sine for? Wherever the sine curve touched the midline, we put the vertical asymptotes in because that's an undefined for our cosecant function. Then on the maximums and the minimums of the sine curve is where you draw the U-shaped graph, and it will go away from the sine or cosine curve.
Why don't you include those ones? So like a pi over 2.
All right, so let's take a look at this. We did sine of x first dotted line, but I'm going to just do 1 divide by the sine of x. Mode, I need to switch into radians. You can be in radians or degrees. I'm just going to go to radians. So when I do my window, I'm going to have my window go from 0 to 2 pi. When I put in 2 pi, the calculator automatically goes to a decimal, so that's why it puts that decimal in. Our tick marks were every pi divided by 2. They went up to a maximum of 1 and -1, so let's just go -3, I guess, maybe to 3, see what that looks like. And so when you go to graph your cosecant, that's all you see. You don't see anything else on the graph, so don't make anything else a solid line except the U-shaped part of the graph. Okay? Secant, we're going to do a cosine first. So it'll be 0, pi over 2, pi, 3 pi over 2, 2 pi, up to 1, down to -1. Where does cosine want to start? At 0, it'll start up at a maximum midline, minimum, midline, back to the maximum, and so it looks like this, dotted. Wherever you hit the midline is where we're going to put vertical asymptotes because it's undefined. And then the cosecant graph, or excuse me, the secant graph, I'll do in the blue. Go to the maximum, and we go away from it. Here we see the full U. And here. So you always leave the maximum or minimum, go in the opposite direction, and then you go against the vertical asymptotes, and it just follows it down forever then. Now some students get kind of bothered by these half U's that you see in places when you graph them, and sometimes they add one more you can add one more critical value to get it to look full. I mean, I used to actually teach it that way, that you couldn't have half graphs.
What if you didn't?
I'm over it now. I'm gonna skip the C and D. We're skipping to C and D. If you want to go back and grab those other two problems, go ahead. But if you look at C and D, there's a cosecant and a secant, and there's a bunch of numbers that are changing. So if we can get these two, you can understand how to do any of the problems.
I can't handle it.
So, with the cosecant graph, what should I do first? First, we're going to do a sine curve. So, what do we have to get down on the graph to do our sine curve? What's one thing somebody knows? So the midline is going up 2. Somebody else? Abhi. Say that again? Okay, so you're going to the phase shift. So when you do the phase shift, you set that quantity equal to 0. And I'm going to switch it to a red color because just to indicate, hey, this is not normally where the first one goes, but because of the phase shift, we went to the left power 4. What do we call that? With sine and cosine, what do you call that? With sine and cosine, what do you call it? So now we're back into sine and cosine mode, so that number does matter. That is an amplitude of 2. So, what does it do? So we're going to go up from the midline 2 more. So we'll go up to 4 and down to 0. So sometimes people put a dotted line at the maximum minimum across also to help make sure you fit in there. Anything else? Okay, right here, b equals 1. So if b equals 1, the period is 2 pi divided by 1 or 2 pi. And we're going to space the critical points every 2 pi divided by 4 or pi over 2. So we're coming right off the tangent or cotangent, which was pi divided by b and period divided by 2. Now we're back to sine or cosine mode, which was yesterday. The full 2 pi divided by b and now 2 pi divided by 4 or period divided by 4. So let's space them out. What's negative pi over 4 plus pi over 2? Positive pi over 4. What's a fourth plus a half? 3/4. 3/4 plus a half. 5/4 plus a half. Now, this, because this is a sine and cosine function, we can take the 7 pi over 4 minus the negative pi over 4, which will give me a total of 8 pi over 4, which matches 2 pi period of function. Where does sine want to start? At 0 wants to start at midline. But remember, we shifted to the left pi over 4, so that's where the dot should go. Am I going to have a dot on the y-axis? No, because the next critical value is this pi over 4 here. So then we'll be at a maximum there, and a midline there, and a minimum there, and back to the midline there. So that's our sine curve. But we're supposed to be graphing cosecant. So anywhere that touched the midline, anywhere it touched the midline, not 0. Anywhere it touched the midline. Anywhere it touches the midline is where your vertical asymptotes go. And so then the U-shaped graph would be right here and right here. So what I'm going to do on the next problem is I will pause it, let you guys work for 2 or 3 minutes on it, and then I'll start putting the stuff up behind you. Here we go. Pay attention. In the back of your head, you're dealing with a cosine because it is the secant graph. We want to do its reciprocal first, cosine. One of the first things I might identify is that my b value right here, that's b. So if b is pi over 2, the period will be 2 pi divided by pi over 2. You always, when you're dealing with sines and cosines, you always take 2 pi divided by b. When you do that, it is 2 pi times 2 over pi. The pi's can get the chunga chunga. We're left with 4. So the period of the function is 4. The critical points then are going to be spaced. Take the period and you divide it into 4 equal parts. We're going to space everything by 1. Okay, so that work is all to get basically to the critical points and how far you space them. Then there's also an amplitude happening. Now the midline is not here, right? So the midline is still at 0, so it's right on the x-axis. So we're going to go up to 3, down to -3. Then we have to consider the phase shift. Oh, that's going to be in the way. Oh, that doesn't work.
It's gonna be in the way too.
Oh. Okay. So my phase shift is that pi over 2x plus pi over 2. I set it equal to 0. I subtract the pi over 2 to the other side. And now when you divide by pi over 2, I have a phase shift of -1. So this means everything is going to the left 1. So I'm gonna mark that in a red so that you know, hey, we shifted it to the left. So normally we would start at a 0 for a critical value, now it's to the left 1. What's the next critical value then?
0.
So we're going back to the critical values right here. We're going to space them every 1. So -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2, 3. And there's 1, 2, 3, 4, 5 critical values down. Where does cosine want to start? At a max. So we're going to have a dot there. This time 0 is a critical point, so I will have a 0, or a dot I should say, on the y-axis. Then the next one goes down to a minimum, then a midline, and then a maximum. Wherever you hit the midline, put your vertical asymptotes in there, and then under this minimum, you'd have a U-shaped graph here, and then a couple of half ones up on these maximums. So when I go to correct it, I do look, are your maximums and minimums located at the correct critical points? And